Hello everyone. In today's video, let us learn how to inspect soldered joints, detect the defects and test the PCB for rework.
At the end of this video, you will be able to inspect the soldered joint for any defects, detect the type of defect in the soldered joint, test the given PCB for rework. Let us collect the tools and equipment required to do this practical. Trainees toolkit, magnifying lens, soldering iron set 25 watt 230 volt, safety goggles, IPA solution, cleaning brush, cleaning cloth, desoldering pump. Inspection of the soldered joints. Collect the defective PCB for the inspection. Make visual inspection on the board for any physical damage or defect. Identify the residuous flux area on the PCB. Clean the residuous flux on the soldered joint using IPA solution with brush. Spray or flush the IPA solution on the brush, ensuring it is adequately saturated but not dripping. Be cautious not to use too much solution as excessive moisture can lead to electrical shorts or damage to sensitive components. Gently scrub the soldered joints and surrounding areas with a brush soaked in IPA solution. Focus on areas where flux residue is visible, applying light pressure to effectively remove the residue without damaging the soldered joints or components. Using magnifying lens, carefully observe the shape of the joint formation, surface texture, mechanical bonding, and any brown wax-like material. Let us discuss the how to identify the various types of soldering joint defects that usually occur in the PCB. Dry joint or cracked joint. Look for signs of poor soldering such as incomplete solder coverage, irregular shape, or visible cracks in the solder using a magnifying lens. Dry joints or cracked joints may exhibit movement or flexing, indicating a lack of proper adhesion between the solder and the component lead or PCB pad. Dry joints or cracked joints may feel uneven or bumpy compared to properly soldered joints. Poor soldered joint or lifted component. Look for irregularities such as insufficient solder, solder bridges, shorts between adjacent pads, solder balls, or solder spatter. Check if components are properly aligned with their respective pads. Misaligned components may indicate poor soldering or lifted leads. Look for components that appear raised or tilted on one side. This could indicate that the component is not fully soldered to the PCB or that one or more leads are lifted. Excess solder on joints. Look for signs of excessive solder such as solder blobs, solder bridges, shorts between adjacent pads, or solder spatter. Examine the shape and profile of the solder joints. Excess solder may form irregular shapes or bulges, particularly around through-hole components. Wetting defects. Look for signs of poor wettings such as incomplete coverage of solder on component leads or PCB pads. Examine the solder fillets formed at the junctions between component leads and PCB pads. A properly wetted joint should have a smooth, concave shaped solder fillet with good contact between the solder and the surface being joined. Blowholes. Look for signs of blowholes such as small cavities or bubbles within the solder. Check for irregularities in the solder surface such as dimples or depressions which may indicate the presence of blowholes. Temperature defects or overheating. Carefully examine the PCB surface and components under good lighting. Look for signs of temperature-related damage such as discoloration, burn marks, or charred areas. Check for components that appear deformed, melted, or cracked, which may indicate exposure to excessive heat. Lumps of charred flux. Charred flux typically appears as irregularly shaped blackened lumps. They might have a rough or grainy texture due to the charring process. Flux is usually a mixture of various chemical compounds designed to aid in the soldering process, such as borates, silicates, and fluorides. When charred, these compounds might undergo changes in color and texture. Removal of through-hole component soldered joint using desoldering pump. Take a defective board and identify the component to be removed. Start by visually inspecting the board for any obvious signs of damage or defects. Look for burnt components, cracked solder joints, bulging capacitors, or any other abnormalities using a magnifying lens. Inspect the size of the solder joints on the component using magnifying lens. Carefully examine the size of the solder joints under magnification. Pay attention to their width and consistency. If the sizes of the solder joints are minimal, apply additional solder to form an excess solder joint. Turn on the soldering iron and allow it to reach its operating temperature. With the soldering iron heated and properly tinned, carefully apply additional solder to the existing joints. Touch the solder wire to the joint while simultaneously applying heat with the soldering iron tip. Allow the solder to flow and form a smooth, shiny joint. Identify the defective component that has to be removed from the PCB board. Use a soldering iron to heat the solder joints of the component you want to remove. Apply the tip of the soldering iron to the joint and allow it to heat the solder until it becomes molten. Hold the desoldering pump in one hand and position the nozzle of the pump over the molten solder joint. Ensure that the nozzle is directly above the joint and forms a good seal with the board. Press the plunger or trigger of the desoldering pump with your thumb to create a vacuum. This vacuum will suck up the molten solder into the pump's chamber, removing it from the joint. After engaging the desoldering pump, release the plunger or trigger to release the vacuum pressure. This will allow the solder to remain trapped inside the pump's chamber. Repeat the desoldering process until all solder is removed. After using the desoldering pump, inspect the solder joint to ensure that the solder has been completely removed and the component is free to be lifted from the board. Once the solder has been removed, carefully lift the component from the PCB board.
In this video, we have learned how to inspect the solder joint for any defects, detect the type of defect in the solder joint, test the given PCB for rework. This concludes the exercise. Thank you for watching.